All right, good morning. Who's here? Let's see. There really shouldn't be a delay today, but there might be. Good morning, Luz. Hi, Aaron. We'll give it a couple more minutes. Good morning, Magali, Myra. You all are so awesome. How's the sound? Is it better today? Good morning. Is that Mortimer and Daisy? Okay, perfect. Hi, Jennifer. I love seeing your names pop up. This is so fun. If you hear my dog snoring, I apologize. He is very tired. But we will get started. We are going to work today with solving equations when we have a variable on both sides. Hi, Miss K. And we're also going to talk about when there's one solution, no solution, or infinite solutions. So let's first start. I took off the delay so that if I ask a question, you should be able to respond right away. So hopefully that works. So our first problem here, we have 2x minus 6 equals 5x plus 18. When we're solving an equation, we have to get the variables to one side so we can isolate that variable. Here it's an x. Anyone have ideas with what we can do to isolate the variable? I'm not sure how easy it is for you all to type. All right, well, I'll just start to solve this. In this scenario, we have our 2x here and our 5x. So what we can start to do is remove this 2x. I really don't want to have variables on both sides here. So I know that I can subtract 2x. The problem is if I subtract 2x from here, I also need to subtract from the other side. And who can tell me why I need to do the same thing to both sides of the equation? That one I want to wait for. So I'll rewrite this while somebody tells us in the chat why we need to do the same thing to both sides. No one? So now we've simplified. And to go back, we need to do our operations to both sides so our equation remains balanced. I can do anything to one side as long as I do the same thing to the other. My value of both sides, they're still equivalent or equal. So now let's look down here. We removed our 2x, so we're still left with a negative 6. Really key, that's a common mistake. A lot of students just say that's a 6. That's a negative 6, and it equals 3x plus 18. So now we have our variable isolated to one side. It's right there. But we need to get it by itself. So there's two things happening. Yes. So good, Aaron. The next thing we want to do, we want to move the constant to the other side. There's two things happening here. X is being multiplied by 3, and then we're adding 18. So remember, we did in class that building. We multiplied by 3, and then we're adding 18. And in class, we undid that. So the first thing we would do to go back is subtract 18 and then divide by 3. So we're going to do that. We'll subtract the 18 from both sides. So now this is no longer here. I only have a 3x. On the other side, this is a common mistake. It's negative 6 minus 18 is a negative 24. So lastly, we did this part, check. Last thing, let's divide to get our variable isolated by 3. So our answer here, negative 24 divided by 3 is negative 8. The chat is actually coming through a little delayed. I am assuming that there's a lag in what I'm saying. So it's okay if you keep commenting because you're following the procedure completely how we would. So in this scenario, x is negative 8, and I can check that. So I'm going to erase all this because we don't want to just get x equals something and walk away. We want to make sure. So how can we make sure? And I'm sure some of you are going to type that in, but we make sure by substituting back to see if it works. I'm getting much better at hand drawing with these markers, but it's still tricky. So here we have negative 16 minus 6, which means that whole side. Let's see if I can just move all that. Good. So negative 22 equals. See how this works. 5 times the negative 8 is negative 40. And then we're adding to negative 40, 18. So if I have negative 40, to break it up mentally, I can add 10, which is negative 30. And then I can add back 8, which is negative 22. So this is how I can check. We know that negative is our solution. But did we have to start this whole problem by subtracting 2x? That's the first thing we did. We took 2x away and 2x away. We don't have to do that. We could have taken 5x away. And I'll just go through that somewhat quickly. So if I eliminated the variable from this side, I'd be left with 18 over here. And then this would be negative 3. Again, the sign matters. Minus 6. So then from here, same concept as before. I'm undoing everything that's happening to my variable. So negative 3x equals 24. And this will give us the same result. We can actually solve many ways and still come out to the correct answer and the answer we were looking for. So in this scenario, there's one solution, and it's negative 8. So let's look at another one. This scenario, we have a little bit of distributive property here. So let's start. This represents two groups of 3x minus 6. So I really have a 3x, a negative 6, and then another 3x, and another negative 6. So I really do have 6x and a negative 12. Now in class, when we do this, we tend to distribute, we multiply. We know that this is 2 times everything inside. And sometimes we use a little arrow just to show so that we know we're multiplying properly. So on the other side, we have this. Does anyone know what that's doing or how we can attack it on the right side of the equation? So some of us look at this and see a -1. Some of us visualize that, right? And some of us like to distribute and say -1 times 12 is -12. Perfect, Mortimer. And then -1 times the -6 would be plus 6x. Some of us don't look at that and see a -1. Hi, Darwin. Some of us don't look at that and see a -1. Some of us just see subtraction. And you're not wrong, because here you are subtracting a +12, and then you're subtracting a -6x. So think about what happens when we take away when we take away a positive, that's subtraction or a negative. And then when we take away a negative, that's the same thing as addition. Some people see that the signs just change, but it's more than just changing the sign. There is an actual operation going on that's doing that. Okay. So no matter how you see that, whether it's a -1 distributing or subtracting everything in like that, you're correct. We want to be careful, and a lot of you do this, leaving that double sign, because I see in a lot of the work that you're doing, there's confusion. Some of us are leaving this and just assuming that it's subtraction. So we want to make sure that we simplify that. But let's move on. We have our equation here. 6x minus 12 equals -12 plus 6x. Now, some of you may see already what's happening. You may already see the number of solutions or the issue. So, but we're going to keep going because we don't want to assume, and it's good to just solve and figure it out on your own. So if I wanted to add my constant, I want to get rid of the 12 here. So I'm going to add it. I'll add to the other side as well. When I do this, I'm left with 6x on the left side, and I'm left with 6x on the right. So again, some of you may see again that this is an equation that has infinite solutions. But I can go one step further. If I wanted to really isolate this variable, I could divide both sides by 6, right, to prove even further that in this scenario, no matter what my variable is, it will always be a true statement. And going back to this beginning, the start up here. A lot of us, when we solve equations with variables on both sides, we want to do something with the variable first, which is completely okay. That's your choice. And that's what I typically do when I solve. So if you wanted to subtract the 6x, I'm going to get the variables off of this side. I'm going to get them, just isolated to the other side. You could do that. Take the 6x away. Do the same thing over here. Now that's gone. So I'm actually left with -12 equals -12. So then you have to ask yourself, what's going on here? And this equation says -12 equals -12, which we know is true. And we know it's always true. So this is another example, another way you could see that this equation has an infinite number of solutions. And what throws us off, some of us, is that when we have this equation, 6x minus 12 equals -12 plus 6x. Some of us look at this and can't see that there's an infinite number of solutions because we don't see that these are identical. And they are identical, but they're just in a different order. Here we are combining 6x and a -12, It's not really subtraction there, right? Because if you look on this side, we're adding together a negative 12 plus 6x. The order just changed. And if you could type in the property that tells us that the order of addition can be moved around and it would still be the same, I'll be really, really excited. So if someone wants to type what property tells us the order doesn't matter when we add. So that scenario is an infinite number of solutions. And you could test this. You can put in any number and substitute it in. Any number would work. And also, if you make a mistake, yes, Darwin, commutative property, thank you. Good, perfect. It's actually here, I'll spell it for you. Think of commuting, like I commute to work. So I go there and back, like the order doesn't matter. Good, Aaron, perfect. So in this scenario, if you made a mistake, and the mistake that we see the most would be this. Sometimes students say like, oh, we're going to subtract 12. So then all of a sudden it's negative 24 plus, this is wrong, right? This is an error, but this is what happens. This is what we see. So students get here, whoop, I didn't mean to cross that out. They get there and they say that there's no solution. But when in doubt, just substitute something in, and it can be easy. 0, 1. You would see that those numbers would work in the original equation. So if you thought it was no solution, you'd catch your own mistake. And that's what we're really looking for, to catch our own mistakes and to understand why we made a mistake. So the last scenario is here. And to simplify this, we have a few things going on. On the left-hand side, we have our distributive property. I'm really excited about the commutative. But we have distributive property here. We have 4 groups of 2x plus 1. So we have a 2x, and another 2x, and another 2x, and another 2x. Or, because we know we can multiply, it's 8x. And when we distribute 4 groups of 1, we have 4. It's a weird addition symbol, but all right. So on the other side, we have to combine our like terms. Okay, and we want to go over this, like terms, because some of us still get a little confused. Our like terms have the same variable, same exponent. So our like terms here would be 5x and 3x. 9 can't be a like term with 5x and 3x. 9 is a constant. It's that standalone number. Doesn't have a variable. So it can't be combined. So we can combine the 5x and the 3x to get 8x plus 9. So now some of you may see what's going on here. But if you don't, that's okay. Keep solving and you'll see what's going on. For those of us that like to isolate the variable, we isolate the variable first. If we take 8x away, because we want to get rid of it here and have it only on one side, you would see that doing the same thing to both sides, you'd be left with 4 equals 9. Can 4 ever equal 9? And you could write that in your chat, your answer to that question. Can 4 ever, ever, ever equal 9? Take a sip of coffee. Hopefully you're in the process of typing now. Yes. Good job, Mortimer. Good, Daisy. Good, Darwin. Good. 4 can never equal 9. So there can't be a solution here. Okay. Good. Everyone's chiming in now. Good. We see that. If you went this far, you would see that 4 can't equal 9. And sometimes you might think, I made a mistake. But let's backtrack, because you'll always have time to backtrack. I'm going to go back up here and rewrite this. I really like the purple. It's actually like a really pretty purple. All right, so we have our 8x plus 4 and our 8x plus 9. Once we simplified the original equation we got here. If you saw the 4 equals 9 and were confused, you could try something else. What if we removed the 4 from both sides? Then when we rewrite our equation, it's 8x equals 8x plus 5. So now there's a problem, but we can go even further. If you're at this level and you see there's no possible way I can multiply a number by 8 and it would equal the same number times 8, but then adding 5. This side will always be 5 greater. But if you didn't see it yet, if you isolated all of your constants to the right, you can actually eliminate your variable so you can get all your variables to the left. So I'm going to get rid of this and I'll take away that same 8x. That's a weird x, but it is an x. So now I'm left with 0 equals 5. And again, very similar to before, 0 can never equal 5. So this problem would have no solution. You could check it. The problem is you could check forever because no number would ever work. But if you started small, like the number 0, if I substituted in a 0, then this would be 4 and this side would be 9. And that's just not possible. So we know here there's no solution. But still, we did the same process. We simplified and we started to solve. Some of you see it early, and some of the problems that we do in class are not intentionally meant to trick you, but they do throw you off, and some students assume. So you still have the option of going further and simplifying. So to recap a little bit, when we solve equations, just in general, and we have variables on both sides, there's quite a few things that we do. We typically start by simplifying. These are the 3 that we did. In the second one, we use the distributive property to simplify. In the third one, we use the distributive property and we combined like terms. Okay? Once we simplified our equations, we were able to isolate our variables. In the first scenario, when we isolated, and the key here, we knew there would be one solution because of this. Because on the left side, we had a 2x, and on the right side, we had a 5x. Because that variable was different, I knew I could keep going. It's not like if I eliminated from one side, my variable would be gone. Like in this scenario. In the second example, there couldn't be just one solution. It had to be either infinite or none because I have 6x and a 6x. So I know if I take one away, if I removed one from the left side, that it would also be gone from the right. So I have to look a little further and I need to compare the constants and actually try to solve. In the last scenario, when I simplified, I did have an 8x on both sides. Okay, so I knew it couldn't be just one solution. It would have to have been multiple or none. But I had to go a little further. And seeing the differences in the constants could have been your hint if you didn't need to go further. Now, it doesn't matter if we have an equation that has fractions or decimals. It's still the same concept. If I had, oh, that's yellow. I don't want to use yellow. If I had 1/4 times 4x plus 8 equals 2x minus 3. Same process. I still need to simplify. If I distribute my fractions, I have x plus 2 equals 2x, a little sloppy here, minus 3. And then same thing, you choose. But your goal here is you need to isolate your variables. There's 1 here and there's 2 there. So I don't love when I do this myself, and you don't have to do this, but I don't like to have a negative variable if I can avoid it. So here I would choose to subtract the x. Now this doesn't become 2. It's not like, oh, this is the x and this is x, so it's gone. It's actually 2x. I have 2 of something, and I'm taking away 1 of that same something. So I'm still left with 1. And then the rest of the equation is still here. Now in this scenario, x is here. We're subtracting 3 to get x alone. We would add 3. So x equals 5. Now I knew just looking at the beginning that there was going to be one solution, because I knew just doing it in my head that when I distributed this, that was going to be 1x. And over here, there was 2x. So I knew there had to be a solution. Wasn't sure if it was going to be a whole number, but I knew there would be a solution. And those are the things that you'll start to see the more and more you solve these equations. Does anyone have questions? It's a good time for questions. I can use another example. If there's something specific that confuses you, type it in. While I wait for some questions, I will say, if you are looking to do any type of practice work, I put up on the website, www. I'll actually type it up here. I think most of you know it, but www.mathwithmrsc.com. Yesterday, I put up a pretty decent sized post. Actually, it might have been Sunday night, with options for things that you can practice. There's solving equations with variables on both sides. There's one solution, no solutions, infinite solutions. There's also like distributive property, combining like terms. I also put out literal equations. We talked about literal equations yesterday on this live feed. If you didn't tune in, you can actually watch it on the YouTube page. And that is actually the only other learning target we've worked on in the honors classes. So on your unit exam, which is a week from today, you'll take it next Tuesday. You'll have everything that we've learned so far. The only other thing we are working on before that test, and we're doing it tomorrow, Thursday and Friday, is solving inequalities. Just like an equation, but it would be for something like this. So that is the inequality that we have: less than, greater than, less than, equal to, or greater than, equal to. If you want to get a head start on that, you can let me know, comment here, and I can actually put up a few things for you to do prior to tomorrow. Just let me know. And if you need anything, you can email me. You can direct message me on Instagram, or you can go to the website and you can actually comment in on the right side. That will come to me as an email. So if there are no questions, I'll actually end it here. Thank you for coming. It's kind of weird that we're meeting online, but if this works, we'll continue to do this, especially as we're preparing for Mortimer. You want the inequality stuff? I'm assuming that's what you meant. I could post some inequality stuff. But these online mini meetings are going to be really helpful as we move through the algebra material, because we are trying to learn. No problem, Luz. I'll post it right when I get off here. I'll post some stuff on the website. So check around 10, and there will be a link there for a few things. Perfect. Yeah, but anyway, this is going to benefit us as we move forward, especially if you're able to tune in, whether you're on a computer or a phone. And I think we resolved the sound. Hopefully, Jennifer, you can hear today, because I know yesterday was rough. But thank you guys for coming, and I will see you tomorrow morning, and I will post that link in the next 10 minutes or so. So if you want anything on inequalities, you can log on the website in about 10-15 minutes, and it'll be there. At least 10 o'clock, if I can't find anything right away. All right, good night, everyone, or have a good day. Enjoy your day off.